Hello PHS algebra students, this is Mr. Montes again, and I didn't have a chance to do some more examples, so I wanted to make a second video for this second lesson for distance learning for dividing powers. So I have the example instructions, and what you're going to see at the top of your assignment this week. It says use the properties below to simplify each expression, writing your answer using positive exponents. That's going to be an important factor. And last week we gave you all the product of powers, the product of power, and the distributive property of exponents. For this lesson that you probably just watched, we're talking about the division of powers, where we can subtract the exponent of the numerator by the exponent of the denominator to simplify. We talked about what negative exponents represented, which is taking the reciprocal of this a to the power of n. And then we talked about the zero exponent, where any number to the power of 0 is going to equal 1, except for the situation where we have 0 to the 0, which will be undefined. So let's just jump into some examples. Let's see. Let's start off with a pretty straightforward one. Suppose we had, let's say, 3 to the power of 5, and I was dividing that by 3 to the power of 8. Alright, so according to our properties, we'd be using this one right here. So we're going to go ahead and do that. So this would be, we have the same base. This would be 3 to the power of 5 minus 8, which is equal to 3 to the power of negative 3. And as far as being simplified, you're about 90% of the way there, with the exception of that we have a negative exponent here. And if you look at the instructions, we got to write it using positive exponents. So what we're going to do is we're going to go ahead and use this right here. And we're going to rewrite this as 1 divided by 3 to the power of 3. And just like I mentioned in the video below, we can think of this as moving down to the denominator or up to the numerator, depending on where it's at, just to make things simpler for us when we do this. So that's the first example. So we took 3 to the power of 5 divided by 3 to the power of 8, and we turned it into 1 over 3 to the power of 3. At this point, don't worry about simplifying 3 to the power of 3 or rewriting that as 3 times 3 is 9, times 3 is 27. Just leave it as 3 to the power of 3. 1 over 3 to the power of 3. Alright. So let's get rid of this. And let's try another one. What if, let's toss a little curveball in here. What if I had a to the power of negative 2, and I was multiplying that by a to the power of 6. So a little bit of a combination of our first lesson as well as our second lesson. We're multiplying here. We're not going to worry about this being a negative just yet. But because we're multiplying, we're going to utilize this product of powers. We're not going to forget all the other properties that we learned about. And I'm going to rewrite this as a to the power of negative 2 plus 6. Simplified down, negative 2 plus 6 is going to be a to the power of 4. And I am done. So using the product of powers, I really didn't have to worry about this negative 2. However, there is another way to do this. And I'll show you. I could have instead of the product of powers, I could have used this negative exponent rule first and changed this into, remember, think of this as moving up or down. So we're going to move this down to the denominator. We're going to leave this a to the 6 on its own. A to the 6th, a to the 2nd, and now it's positive. So when I moved it down to the denominator, it turned into a positive exponent. And then I can utilize my division of powers, rewrite this as a to the 6th minus 2, which is equal to a to the 4th. So 2 ways to get to the exact same spot. And that's kind of the beauty of some of these problems, is that there isn't exactly one way to do it. And as long as you use the properties correctly, you can go about it any way you really choose. Alright, so let's get rid of this. Get rid of that, and let's try another problem. Suppose I had something like this. Suppose I had 8a to the negative second divided by a to the fourth. We're going to simplify this. Now, what we need to recognize is the fact that we have 2 bases here. We got the base of a here and here, and then we got a base of 8. So I'm going to leave the 8 on its own. There's nothing I can really do with it. 8. And then this right here, I'm going to use the division of powers rule. And I'm going to rewrite this as a to the power of negative 2 minus 4. Alright, so now 8 stays there. The negative 2 minus 4 is going to be negative 6. So I got a to the negative 6. And I'm going to rewrite this. We're going to think of this as being over 1. And I'm going to take this because it's negative, and I'm going to move it down using the negative exponent rule. So I have 8 divided by a to the 6th. Done. Perfect. Alright, so let's try maybe, let's do maybe one or two more. Let's get rid of this stuff. Let's make it a little bit more complicated. Let's try x to the power of 2 times y to the power of 3. There we go. And let's have this be x to the power of 2 y to the power of negative, not 3, let's go negative 2. Alright, so I have a division of powers. I have a base of x, and I also have a base of y. So I'm going to deal with those separately. So I got x to the power of 2. Now I take the 2 and I subtract off 2. I'll worry about simplifying that later. Times y to the power of 3 minus 2 minus negative 2. So interesting thing that happens sometimes is because this is already negative, students forget, or people forget in general, that we're still subtracting. So it should be 3 minus what's down here, whether it's negative or positive. So here I have 3 minus a negative 2. So I have to make sure I include the negative from here in my work here. So let's simplify this. We got 2 minus 2 is 0, so that's x to the 0. It doesn't disappear. It just goes to x to, turns into x to the 0. And 3 minus a negative 2, well, we can think of that as adding. So that's y to the 5th power. We are almost done. We have an x to the power of 0, which gives us this scenario, and we turn into y to the power of 5, 1 times that. But we don't need the 1, we can just write this as y to the power of 5. And we're done. So this whole gross looking thing here, and this keeps popping up, I'm so sorry. There we go. This thing turns into this thing right here. So simplifies down to that. And I think, you know what, we'll do one more. Let's do one more. And you know what, the thing about watching a video online is that you get a chance to actually rewind and pause whenever you need a little bit more time to take in the information. So if it feels like I've gone a little bit fast, rewind the video, watch it again, pause it, positive strategic points, try to figure out what it is that I'm doing, or what property I'm using, and so on. So let's do one more. Let's do 3a to the power of -2, b to the power of 5, divided by 3 to the power of 2, a to the power of 6, and b. Okay, so in this case I have 3 different bases. I got 3, the base of 3, I got a base of a, and then I also have a base of b. So deal with those each separately. I'm going to use again this division of powers rule. Now something that people forget is that there is an imaginary 1 up here at the 3. So this should be 3 to the power of 1 minus 2. This down here, up here will be a to the power of -2 minus 6. And this is going to turn into b to the power of 5 minus 1. Now again, even though there's nothing there, we can think of there being a 1 right there. So sometimes it's put in there, sometimes not. Make sure that if it's not, you still think of it conceptually as being there. And then we can simplify this into 3 to the power of -1 times a to the power of -8, and then b to the power of 4. Simplified down, we used the division of powers rule. Now we're going to have to, I have no idea why that keeps popping up. Now we're going to have to utilize the negative exponent rule. So I'm going to think of this as being over 1. And anything that has a negative exponent, I'm either going to move up or down. In this case, negative exponent, move down. Negative exponent, move down and make it positive. So this is b to the 4th divided by 3 to the power of 1, or I can just leave it as 3, and then a to the power of +8. And I am done. So this thing right here turns into that thing. As always, if you have any questions, please email us. Let us know if there's something that you don't understand or something that's confusing, or maybe I did something wrong here. That happens sometimes. And we will get back to you. I know teachers are checking their email at least once a day, to make sure that we're responding to your needs. If you haven't watched the first lesson, the lessons are posted on YouTube. I'm going to try and send out the videos again. I know a lot of people didn't receive them last week for whatever reason, so we'll get those resent out. But in any case, have a good day, and we'll talk to you all soon.